DraftScience video presentation where I attempt to reason with the reasonable, if there are any. So, there is a dispute here about what science says. Okay, so there's subjects in physics where you just won't get the same answer to the same question from every physicist you ask. Will give you some different interpretation. And some of them, in some cases, these interpretations are dramatically different. I mean, so contradictory. One says momentum is always conserved. The other one says energy is always conserved, kinetic energy, or some notion of it. But you could argue that they all have fundamental misunderstandings, misunderstandings of some kind or another, in the sense that there are misunderstandings and there's overt evidence that it doesn't work the way they say. So Pirro has answered, sort of. I mean, you could say they're answers, but they're not really answers to the exact question, because he just basically changed the question, changed the premises of what science says. And so you have to go back to the arguments he's making and saying, science says the same compression of a spring can create different momentums. So if I compress a spring and I put a different weight object in front of it, he says that object can have various different momentums. Now, there's pretty much overt evidence, experimental evidence saying it doesn't work that way, and that's ignored. Okay. And he just keeps arguing from this very false premise, in the sense that this one he's wrong on. So in some sense, he says physics girl is wrong. Now, he won't publicly say physics girl is wrong. He won't say her physics is nonsense and garbage, but she's saying exactly the opposite. She's saying momentum is always conserved, and it's kinetic energy that's fudgeable. Professor Lewin overtly says, it's even in this video, I think. Maybe we'll play that part. I mean, I'm trying to spare you. I've already played this like 6 times. Clearly can't screw with momentum. Momentum is king. And yet Pirro says, no, I can change the momentum. I can change how a force imposes momentum. I can tell the force you don't have it, or I can tell you got extra. And you can't do any of that. So the premise is quite debatable, and yet he states it as if science says, and it's not what science says. And he'll take no account for the fact that it's not what science says. He won't refute Lewin, and he won't refute any of the other scientists. And I say other scientists, sarcastically, because clearly Pirro doesn't care anything about the scientific method or any of the rules of establishing what science says. So the point is, you have to be very careful about conclusions, and this is all a process where you have to put all the ducks have to be in a row. You have to, the game doesn't work any other way. You have to arrange all the pieces. This is a puzzle. You can't have extra pieces left over. You can't use a hammer to smash them in. I mean, these are simple arguments. And basically what's happened here is there's a bunch of people out there, you people, who think, yeah, that's exactly how it works. We do get to do all of that, because we can force it to look the way we want it to look. And they won't concede that physics might have made some obvious and catastrophic errors, that there might be parts of physics that are not physics, they're religion, they're something else, they're not rational ideas. And again, just a bunch of very poor arguments. I mean, very little evidence being shown, and then very little description of evidence in any kind of honest way, i.e. the Stephen Bro video that's obviously got very conflicting results out of his playing with the ideas, and yet he concludes, yes, it's overwhelming proof. Obviously it's not. I mean, it's obviously not overwhelming proof. So I don't know what to say. Like I said, it's clearly people are unreasonable, and they're showing it in this panic, and they can't have their sacred science scrutinized, and because it's a sacred religion, it's not a science. It's a religion, and they're just individual preachers with their little individual interpretations telling us what the, one preacher says, oh, Jesus loves homos. Another preacher says, oh no, Jesus wants you to go to hell and, suffer for your sin. They don't have any consistent story, and either does science. Science says, and it just might as well be science pen, tree sloth. So, it doesn't mean anything. It's incoherent what science is saying, because it's lost. It's the boy who cried wolf thing. I mean, they're so arrogant, so pompous, and yet they're so obviously what one scientist is saying and what another scientist is saying don't agree. And that's a problem. So there is no science says. There's just people say. And you have to judge how disciplined those people are in making these arguments. Now, in this case, Professor Lewin's doing an experiment, and he's going to editorialize on what he sees. And that's what they all do. They add their stuff. And some of that stuff is nonsense. Like Professor Lewin will tell you there's 2 voltages in one location on a wire. and that's somehow possible. That there can exist 2 different voltages in the same location in space. Now, I would argue that that's just silly. You got to you got to go find where you made a mistake, okay? Because that can't be the truth. And obviously he is making a mistake, and he's just ignoring it because he can't accept the fact that he spent years, arguing something that's, nonsense. And that's kind of obviously nonsense. I mean, in the sense that it's kind of obvious the error. But anyway, we won't go back to that subject. All right, so a little bit of background. Let's just call it. We'll do some physics, and then get to the blah blah and the the irritating bits. So, in thinking about explosions and force and all of this stuff, you could think about a gun. And if I had a gun, all right, and I made it as simple as possible. So I thought of a childhood memory of a zip gun. So when I was about 16 or so, a friend of mine was good in the machine shop, and he made a tube, okay, that had a little internal machining done, so a bullet would fit in there, but not go all the way through, so it's just like a gun. And then you used so that was in here somewhere, where the bullet would sit. Okay, and then you just used a rod, with a little dimple on it as a firing pin, and you smash the bullet and you shoot the bullet out of the tube. And, it's called a zip gun. So the idea is what you're saying, what would happen in these different circumstances? Now, I thought the whole thing was like a, disaster waiting to happen, right? And you've got to take the full recoil, is happening, mostly on this rod that you're using, because it fits into the, hole in the gun. And so it just makes the whole thing kind of dicey, because this will gain a high velocity because it doesn't have much mass. So you're shooting the bullet, yes, but you're also shooting the rod out of the other end, and and also the whole thing could just blow up and shatter like a pipe bomb. So yeah, I mean, I was smart enough to say, I don't really think I need to do this. And that's because I had other experiences in life that also taught me some physics. So, in another example of, I'd also say it's sort of an example of irresponsible jackass parents like Piro. Some neighbor parent on the 4th of July was doing fireworks. And I don't know how I happened to be available, but I just happened to be. I don't even remember the people, that I wasn't like some friend's house or something. It was like the neighbors of a friend's house. And well, anyway, so a crowd gathered for whatever reason, and I happened to be part of the crowd, and I happened to be brave enough. So the idea was he had bottle rockets on an airplane, a little cardboard airplane, and a big M80, because it was going to be fun. That's like 1/8 of a stick of dynamite. So you know, it's going to be big fun, bottle rockets, and then a big explosion, you know, blah, 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 blah. So there was an idiot volunteer to hold, you know, to throw the airplane, because the only way it was really practically going to work is you have to get the plane going in the right direction so the bottle rockets could really shoot it. All right, so I was the idiot volunteer. And so, of course, the idiot parent, not being very good at physics, you know, he first knew, oh, yeah, I got to light this one first, right? And then I light these two because I don't want these to go off before I light that. So, of course, he lights this one, but he doesn't account for the fact that he's taking too long to light these. And so what happens is this explodes before it has been launched. Okay, so my hand is right there, you know, on my little, you know, me. Okay, so me is holding the airplane and it explodes, which wasn't any fun. And I really thought it blew my hand off. You know, I wouldn't open, you know, it took me a couple of minutes to have the courage to open my hand because it really felt like it was blown off. You know, it was completely numb. But anyway, no real hard damage, just a little bit of burns, this and that. So that's the interesting part. So, okay, so to make the story relevant, it makes you think about explosions and how you can dissipate them or how you can change them. So if I went back to a gun, all right, and I don't put anything at one end, and I just fire a charge here, and it's completely open here. So this is sort of like the first guns. You know, you'd put a wadding in, you know, cotton. You'd have your gunpowder. You have gunpowder here. All right, then you'd put some crap in to fill all the void, so you know the pressure can push the ball. So really, it's the cotton you put in here that's really pushing the ball. You know, just making a tight seal, and so it shoots the ball out. Now those guns were pretty open. I mean, the fact is the exhaust would go flying out. You know, you had to be kind of careful not to be putting your face in the wrong place, because you're going to get some blowback if you looked over the gun a little too much. You know, you'd get a face full of it. So in principle, there wasn't much stopping. You know, there wasn't anything here. There wasn't some brick wall. Okay, so it forced all the energy this way. There wasn't any such thing. It was pretty much open. The explosion goes this way, the explosion goes this way, and the little ball comes flying out. So in a sense, it's working almost without, you know, it's just an explosion in space. That technically, you could just say, so here's an explosion in space, and I have a bullet right next to it, a little piece of metal, and I want to shoot the bullet. So I have the explosion. Well, the explosion goes both ways, and you really can't change that. It's going to explode both ways. There's going to be stuff, like a pipe bomb. This goes off. And there's stuff going this way, and there's stuff going that way. And you really can't do much about that, okay? But the trick is that, yes, as the explosion starts exploding, okay, the fact is the pipe bomb will start moving this way because there is nothing in its way. So the center of its gravity, so to speak, will move. So in the case of the M80 and my hand, the fact is the explosion pushed, okay, essentially some of this stuff, okay, the first little bits, the highest velocity bits, did hit, okay, and bounce back and push the center of gravity a little bit further away from my hand. And my hand did move away. So those two events put together means that less of the light could hit my hand, because the further away you get, the smaller percentage of the explosion will hit you. So the more distance between me and the exploding object, the better off my hand is going to be. So that's sort of the principle. But you really can't undo the fact that the energy does go both ways. So we take that one step further and let's say when you're making a gun, what are you doing really, right? It's the zip gun. Okay, you got a rod in here that's going to go this way, and you got a bullet here that's going to go that way. And what's the basic principle? Well, the basic principle is this is what I make the gun out of, right? The gun stock and everything else is tied to that rod. The zip gun rod is essentially the stock of the gun. And so now the whole weight of the gun is this rod. And so now it has to move a much heavier mass. So the explosion this way is moving a very heavy mass. The explosion this way is moving a very small mass. you know, small mass, large mass, but they get equal and opposite. They get half the energy goes this way, okay, and half the energy goes this way. And you can't do anything about that realistically. And that's partly because the gun is, it focuses the energy, right? Any energy in here gets reflected. It can't get out except that way. It can't escape this way and that way and all that kind of crap. So it has to go that way, and it has to go that way. And springs essentially work fundamentally the same way. So, yeah, did I emphasize this enough? Yeah. So, I mean, that's one of Newton's laws, is that it's equal and opposite reaction, but it's not a reaction. It's equal and opposite action. These are just actions. Okay, they're not reactions and actions. They're both actions. There's action in both directions when you're causing a force. When you create the force, it's in both directions. Okay. I should be doing this properly, but whatever. I have to, yeah, shouldn't do that. Makes my world dusty. I'll take it outside with me. Anyway, all right. So there was somewhere I wanted to go for the from there. Train of thought has just crashed. So the gun, the momentum, both ways. Spring. So another trick of the spring, so I have a spring, an uncompressed spring, and it's relaxed in all locations. The trick is when I compress the spring, it doesn't compress here. It compresses on the this end, okay, and then it gets loopy, and then it compresses at this end. This is how it compresses. The outside bits compress more, okay, than the inside bits. So there's no way for pressure, really. See, this is the low pressure here in the center. You think that's the high pressure, but no, it's really the low pressure. The high pressure is here and here. So there's no real way for me to send pressure, an impulse this way, and have it go through this barrier in the middle of low pressure. It really can't do that because the pressure's going that way and that way. So all I can really do is I push electrons on a surface, and those electrons end up just pushing back. If the whole atom, see the electron's sitting here, the spring is pushing on it, the electron pushes in, okay, but the problem is if the whole atom doesn't move, then the electron just has to push back again. So it just reflexes back to its original condition. So it doesn't push out, it just pushes back to some default. Just like the Earth is doing the same thing to you now. It's not pushing you up against gravity. It's just restoring you to the condition that gravity took you out of. Gravity pushed you in, it takes you back. It pushes you in, it takes it back. So you never go this way. So this side can't, this side's pressure can't get to the other side. You know, it can't really move anything, and it can't move this center of gravity because the center of gravity is saying, I'm fine. Okay, I got no problems. If you get me. Alright, so that's the basic principle. So you can't move this center. You can't, the explosion can't just freely go this way. Okay? And it's an explosion. It's pushing both ways. Alright, so there's no, as this Professor Lewin video will show, what always happens with a spring, okay, is that it doesn't matter what's on one side because everything's happening way too fast. You know, these are all electrons moving inside of the spring. You know, they're all trying to get back to their original condition, their comfortable condition. They're in an uncomfortable, they're in a bad place magnetically, and they want to get to the comfortable place magnetically. And they do that fairly fast. So the quicker they can get the energy out, the quicker they're relaxed. So if I put different masses on a spring, okay, you know, it's the spring is going to push the mass at the rate it can impose the velocity. So the lighter the mass is, all right, I might make a lighter mass smaller. Let me make it a heavier one. All right, so the heavier it is, the more little atoms it has, okay, and the more, so it can collect velocity. It has to move more bits. So it moves slower, okay, but the fact is the energy is going in at the same rate that it goes into the thing moving fast. The spring is putting in as a percentage of its momentum, right? 10% a second, you could say, or whatever. It'd be obviously much faster than that, but that's what it's doing. It's putting it in the same rate because it's giving this one more velocity because it's a lighter mass, but the rate that it's pumping momentum in, that is putting pressure in, is the same rate. So the momentum's being transferred from the spring. So the spring is momentum. The force is always the same thing. Force equals energy equals momentum. That's Newton's physics. That's what Newton understood. There was no confusion. You know, it's just they didn't have this energy word. You know, I don't know why Newton didn't write force equals mv. He didn't. You know, Newton didn't say. You know, it's another one of the, you know, kind of canards of physics that they say F equals ma, because that's a derivative. I mean, what Newton said was that force equals mass times the change, okay, the change in distance over the change in time. That's what Newton said, and they turned this into this A notion, whatever an A is, you know, an acceleration. But I mean, the you know, the basic concept is, if I want to know how much force it takes, I just measure how much change is happening in the distance over time. Well, it's actually 1/2. But that's a whole nother subject. As you fall in gravity, you acquire the velocity of 9.8 meters, but you only travel in distance, okay, 4.9 meters. So you don't travel the 9.8 meters that you acquire as velocity when you're done. You only traveled 4.9. That's why the half. But anyway, I don't want to get into the you know, I mean, the convolutions of the derivatives is just that. It's just convoluted, contrived. All right, so the point is you can't change. It's like you saying, okay, I'm going to make the explosions explode the other way. You can't make the explosion explode the other way. The only thing you can hope for is reflections to help you out. So let me just do that real quick. But you just don't have enough time for that. So you could argue that if I just have a spring against a wall and I compress it, obviously the spring shoots out and the spring will fly based on its mass at a maximum velocity. So that's the maximum velocity of the spring. It can't go any faster than if you compress it and just release it and let it bounce off the wall. That's its maximum momentum, its maximum velocity. And that's the only velocity it can give something. So if something's really, really light, it can't give it any more velocity than that velocity. And that's it. You know, something less than that actually, because it's losing momentum as it's imparting its momentum into the object. It's losing momentum, so it's going slower. And so there'll be a point where this is going faster than this, and as soon as this is going faster than this can't absorb any more energy, quite obviously. If I'm pushing something 30 miles an hour and it goes 31 miles an hour, I'm not pushing it anymore, right? Because it's leaving me. So that's the principle. The higher the velocity, the more things you can give the energy to, because you don't have to worry about the concept of I can't go as fast as it can. You know, so I can put more energy into it. So that's the advantage of velocity, is you can put more energy faster into something the faster you're going. You can give bigger pieces of momentum to other objects. Alright, so you can get into all the heres and theres of collisions, but the fact is what happens in a collision is, if the object doesn't move, if this object gets hit by this object and it doesn't move, well then this object, you know, essentially the energy says, hey, I didn't get an advantage. The rest of the atoms didn't move, so they're going to go back. The electrons are all going to go back again to their original condition. So you can push in, and then it's going to push back. And that's why things reflect. But you have to wait for that process. This object has to find out that this object's not interested in moving before it can bounce back. So that's a whole argument you can make about timing and how much time it takes for this is all moving at the speed of sound, which is pretty slow. And the force itself is going at the speed of light. You could say the little elemental bits. But anyway, so that's what changes in terms of why things will reflect rather than the energy going both the same, going the same way. So you could hit something with one ball. The one ball goes this way, and the other ball goes some percentage this way, because it wasn't able to get the momentum in fast enough, and the reflection pushed it away. All right. Yes, that's probably enough of all that mush. I still think there was some other point I wanted to make, but I think that's good enough for now. Alright, so we'll play this Professor Lewin video that, again, Pirro won't account for what's clearly demonstrated here.
We got a number, and if we multiply this number by 2.00...
Right, so Pirro is saying that when I throw, say I throw an 8-pound bowling ball, okay, at 30 miles an hour. Pirro's arguing that if I go to pick up a 16-pound bowling ball, I can only throw it, no, I'll actually be able to throw it 11 miles an hour. So let's say it's 18, and yeah, I gotta keep the numbers straight. All right, so it's 16 miles an hour at 8-pound ball. 8-pound ball, 16 miles an hour. If I pick up a 16-pound ball, I'll throw it at 11, because he's saying that somehow it's not going to be half. I'll somehow be able to create more momentum in the ball. So I'll be able to give the ball, the heavier ball, 40 or 50% more momentum. That's how he fixes the broken kinetic energy theory. Is he's arguing that somehow it's... See, he would say that number Professor Lewin just put there is wrong, because it won't be twice. It'll be 1.4. So we've heard this argument before. People say the momentum is different. Now this overtly says that's nonsense. And so they just don't care. They won't correct Professor Lewin. They won't correct Physics Girl. Physics Girl said, that the 5-ton train going 10 miles an hour turns into the 10-ton train going 5 miles an hour. Right? That if I drop a weight on the train and double its weight, I could show you the experiment. So this one's been done. It goes half as fast. It doesn't go 70% of its speed. It doesn't keep 70% of its speed. No, it goes half as fast. That's it. It loses half its velocity. The momentum is conserved. So this is, they're directly contradicting these physicists. And then they say, this is settled science. This is the answer. You can't disagree with us. When clearly it's not settled science. How can you say it's settled science? Here we got prestigious physicists telling you, no, that can't be true. So why are you telling me it's what science says when it's not what science says? It's just so obnoxious.
Then I would like to get this number within the uncertainties of the measurements.
So again, it's supposed to be but Pirro's overtly doing the 1.4 thing. He's saying the momentum changes. I don't get the same momentum this way as I got that way. I get two different momentums.
There is always an uncertainty in any measurement that you do. All right? Make sure that either time is 0. Okay, there we go.
So, double. Exactly as predicted. And so the twice as massive object got twice as slow. This is, you would think logically exactly, just like the trains or anything, that's exactly what should happen. It would be just like that for bowling balls. If I throw an 8-pound ball, I'm going to be able to throw it twice as fast as the 16-pound ball. Now, this shouldn't even be an argument, because let's just make a machine that produces an 8-pound ball going 16 miles an hour and a 16-pound ball going 8 miles an hour. They still are arguing that one of them has twice as much kinetic energy as the other. I mean, logically, how? They have exactly the same momentum. How can they knock down more pins? Momentum is all there is.
What do you see? Ah, 406, 193. Whew! On the button!
Now,
406 and 193.
Well, you make some mathematical error, blah, 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 blah.
3. 0.396, 0.406.
So we'll jump ahead to the point where he basically says you can't screw with momentum.
Close enough. The two are in excellent agreement within the 2.5% uncertainty in each measurement. So, you see, that's exactly how you can demonstrate the conservation of momentum. They picked up kinetic energy, but after the wire was burned, the momentum remained zero.
So again, he says the momentum remains zero because he's talking about their stuff going this way and their stuff going that way. But obviously, the momentum for the trains is not zero. So I guess he said you can't screw with momentum earlier on, somewhere in here.
Nature has no choice. Nature can deal with kinetic energy one way or another, but it cannot finagle momentum. So it must give the more massive car half the speed than it gives the other car.
There, so it's overtly stated. Okay, so Piro says, no, science doesn't say that. Well, how am I supposed to tell what science says when clearly that's what science overtly just said? So how come you get to change the rules and tell us what science really says? When shouldn't we think Professor Lewin should know? An MIT professor should probably know what science says. I mean, it's just such... I mean, it begs credulity. How you can obnoxiously tell me you have the right answer when your answer is in complete contradiction to his answer, and then say you're doing science, right? I mean, frankly, that can't make any sense to anybody. And you won't challenge them. You won't call him a pseudoscience. You won't call him all these names you call me. Why aren't you calling him all those names? Oh, that's right, but you have no integrity. You're a dishonest weasel. Of course, that's the answer is quite obvious. Because you wouldn't want the challenge from somebody like him, because he's going to put you in your place and he's going to show you the experiment as I just showed, and it's going to be intractable. You're not going to be able to find some weaselly way out of it. So again, it wouldn't matter whether it's a brick wall on one side or not. The experiment's clearly showing two equal carts, they both go away at the same speed. Twice as massive, still this side still doing exactly the same thing. So it really doesn't matter, right? I put half the mass there, it does this. I put twice as much mass, it does exactly the same thing. So clearly the bullet just couldn't care less what's over here, so to speak. It just couldn't care less, all right? It just doesn't matter whether there's a brick wall. It's already gone before the brick wall sends the message that, oh, I have some reflected energy to give you. It doesn't matter. The car's already gone before the reflection could get to anything and mean anything. You can't move the center of the spring's mass until it's way too late. You've already shot the other object. It's already gone before it knows, before the spring knows, oh, I can go that way? It doesn't know. Okay, as I pointed out, that's the low pressure point. You know, it takes time, and it takes way too much time. All right. So we'll take a break, and we'll read his comment in this context, and then we'll read his silly answer in this context. Okay. That's all we can do, frankly. Like I said, I can only reason with you people. You're just so obnoxious. There's just no way of talking to you. You're brick walls. Alright, should be back. So this red circle character, he sent me a couple of emails, just kind of gibberish and nonsense, but I'll get around to reading them. I mean, he's mixing the subjects, and he starts talking about alpha particles and all kinds of other crap, and just where you really can't do both kinds of physics in the same place. It just makes a horrible mess. But anyway, in terms of science denial, I have made the same mistake in the past. So he's claiming I'm denying science, which is really rude. And I'm supposed to, what, have any respect for you? Fuck you in the ass till dead, frankly. It seems like the bullet and the gun should get the same energy. Well, they do. I mean, so how did you fuck this one up? It seems like, in this case, no, it's overtly is exactly the same energy. Okay. I mean, obviously, again, this is just about velocity is fooling people. Somehow people think velocity is so special. And it's only special because, yeah, velocity is dangerous to humans. But it isn't special in that it's more energy. Okay, in the Lewin experiment, it seems like the spring energy should be divided equally. Well, it doesn't seem like it's overtly experimental results. The overt results of the experiment are exactly that. The momentum, he can't change it. The spring's doing this and the spring's doing that, and you can't just automatically say, no, I'm going to make it all do this. No, you can't do that. All you can do is come back to where you should be. Just like, again, you're being pushed into the earth right now. What do you think is really happening? Well, obviously the earth is using the reflected energy to just push it back to the same location. So you're stopping right there. You're not going further into the atmosphere. It's not pushing back into the pressure. This side of the spring can't push back into the pressure. It can only stop the pressure from pushing into it. All right. So then he says, this is the part where, okay, the Lewin experiment, right, is the spring experiment. And then he starts talking about alpha particles. The alpha particle taking away most of the energy difference seems counterintuitive. Well, that's because the alpha particle really doesn't have anything to do with an alpha particle, an individual particle. It has to do with what a million alpha particles do. And so, again, it's just more of the nonsense physics, where they say the impossible happens because, of this averaging thing. But it just has to do with each atom is in a different condition. Some atoms are ready to pop, right? It's like a piece of popcorn. Some kernels are already 300 degrees, and some kernels are minus 70 degrees. So some kernels require a lot of energy to force them to pop, and some kernels you just barely, whisper at them, and you're giving them the 2 extra degrees that make the difference. And that's the truth. None of this is true, okay? These are generalizations over millions of particles, billions even. But anyway, I don't want to get into that conversation. It's just more crap where he says this is what science says, but hey, you're not really getting it. It's not really what science says. Maybe it's just a dent in the way some people initially perceive things. So again, all of this crap about no, there's experiments, and you go out and you find them, and you look at them, and you watch them, and you think about it, and you think about it, and you think about it. That's the process. All right, and I'm saying Piro's never done any of that. Okay. It doesn't make us idiots not being able to admit when we have made silly mistakes. So again, where's the silly mistake here? I watched a Professor Lewin video, found it pretty convincing. How have I made a silly mistake? Fuckhead. Or your instincts are off occasionally is a skill many people are lacking. So whatever that even means. This is such trolly crap. I mean, I don't think this person's at all sincere. I don't know. Maybe this is partly just playing a game. So anyway, it's Piro's response I really wanted, to point out. So he says, yeah, and that's why I've been very tolerant. So he's been very tolerant by making a bunch of dismissive videos accusing me of being anti-math and anti-science and an idiot and a moron. That's showing his tolerance. Yeah, sorry. No sale. Yeah, just another lie. Always about people's takes on things. So just more horse shit. Okay. However, if you are wrong, you are wrong. Okay, so Pierrot's not wrong. Professor Lewin is wrong. Yet he won't tell Professor Lewin he is wrong. Nor will he tell Physics Girl they are wrong. Yeah. He'll tell me I'm wrong. Okay. Which things get energy? Okay, which things get energy? The energy flow. So it's just more of his, bullshit baby talk. It's supposed to be physics, and it's the energy flow. Yeah, sure it is. Works a certain way, and often in science, okay, our intuition needs to be retrained. I mean, just a funny, often, he's just such a scientist. So he's just this pretense that he's a scientist and he's doing science and all scientists have learned. And it's just, no, you're a religious kook. Overtly. I mean, well, anyway. When a spring is pushed against a fixed block on one side and a movable object on the other, almost all the spring's energy goes to the movable object. So this doesn't happen. It's not correct. What will happen is if you have an immovable object, the object you put, the mass you put, will be shot off with its half of the energy. And then the spring will leave, okay, the object with the other half of the energy. But it won't be that all the energy goes into the object. The energy going this way will go into the object. No, it'll go into the spring leaving after the object leaves. All right. So he says, for example, he's not going to provide an example. So I just provided evidence. Now, Physics Girl in her video clearly states all the momentum is transferred to the other train. They have the same momentum before and after. So after you double the mass of the train, it has exactly the same momentum. Momentum didn't change at all. Pierrot's arguing for the exact opposite. And he has no evidence of the exact opposite. All right, that's intuitive, right? Question mark. No, it's not actually. It wasn't intuitive. That's not how I looked at it, frankly. So, if you put a spring between two objects, both being movable, the heavier inertia. Okay, so we've been over this word before, but there's no such thing as inertia. Okay, it's just a silly concept. Nothing resists moving. It's just that everything says you have to push me. That's all you have to do. It doesn't resist being moved. It just says you actually have to push me. So there's no resistance to moving. And, it's just the fact that you have to be able to pour the energy in. And the fact is that fast, heavy things, you can't move them fast because you have to give the energy to, you have to pour it in all the buckets, so to speak, all of the atoms. But it's not resisting. It's just saying until you put the energy in, I can't go anywhere. Okay, of the larger objects makes it intuitively and actually less movable. So we just said it. Clearly the experiment shows that the heavier object wasn't any less movable. It actually absorbed momentum at the same rate, and it acquired its maximum velocity just like the other cart acquired its maximum velocity, which ended up being exactly the same. I mean, exactly the same in terms of the total momentum. Mass times velocity. So it wasn't less movable in any way. It just poured the energy in a different way than it poured it into the other object. The other object could go a faster velocity, so it got more velocity. The heavier object could hold more velocity, so it got more spread over more matter. So as with the wall, most, just not all, so more nonsense of the energy will go to the more movable thing. So that doesn't happen. It's not a physical fact. He's claiming it's what science says. It's not what science says. So how do you argue this? I mean, there's no arguing, right? The evidence isn't going to matter, right? There's two pretty clear pieces of evidence. Two rather prominent physicists say so. And yet he's telling me that physics says something different. Well, why don't you show me the different? Show me the experiment that works for you. Show me the 10-ton train having half the momentum, or 3/4 of the momentum, whatever the number is. Show me. Well, it's not actually 3/4. It's 1.6 times more momentum. Somehow, in his scenario, when I drop the weight on the train, the heavier train now has more momentum. Isn't that incredible? It gained momentum by me dumping a weight on it. That's his theory. Because he has to make the kinetic energies balance. But they don't, and they won't. And it didn't happen that way, and that's not what's happening. Because there was nothing, absolutely nothing wrong with the momentum theory. So let's just go back again and look at the history and say, why does this stupid formula exist? What deficit did it correct? It corrected no deficit. There was nothing wrong with Newton's physics. To find out how the energy will flow, you can use conservation of momentum. So those are just words. I mean, he doesn't believe in conservation of momentum, clearly. So what's the point in saying those words? Somehow my same energy will make the heavy ball have more momentum than the light ball. So if I throw a heavy ball, I'll give it more momentum. Somehow my force will generate extra momentum. And somehow I won't be able to give it to the lighter object. Somehow I'm disabled from giving the lighter object the extra momentum. So he's just breaking momentum to fix kinetic energy. And it's overtly not what science says. All right, between conservation of energy and momentum, you can calculate. So just more horse shit. You know, you can watch the damn experiment. You don't have to do any calculating. You can watch it with your own eyes. You can watch Professor Lewin calculate when he says times 2. Not times 1.4. Times 2. Okay, what can be expected from a given setup? So again, just more horseshit that he's calculated anything, ever. That he's ever done a calculation from start to finish. That he's actually done a calculation using F equals ma to explain pool balls hitting each other. When, no, he's never done this calculation. Alright, so the only thing that is interesting here, this red circle just talking to himself here, and then he said, you know, he thanks Pyrrho for, you know, the great enlightenment. It's just very funny. Mass energy need to be equalized. I get it now. Okay, here it is. But in reality, the fairness is to momentum, not velocity. So it doesn't even make sense to talk about momentum in competition with velocity when velocity is a component of momentum. The lighter mass is given as much energy as needed to equalize the momentum. Pyrrho just explained to you how they don't have equal momentums. And so he doesn't even know what he's agreeing with. And now he says, I get it now. Thanks, Pyrrho. You really know your stuff. Now, obviously, this is a troll of some kind. He's just playing word games with Pyrrho here. But, I mean, what the fuck is this? This is just noise. So these are just noise makers who want to, you know, it's difficult enough to have this argument, but these peripheral noise makers just make it impossible for there to be any kind of rational communication. I mean, all of these slanders by all of Pyrrho's followers do stick to Pyrrho in my brain. I mean, I blame Pyrrho for this horse shit. And that's just a fact. So anyway, I mean, the fact that he lets it happen, you know, it's just, you know, oh, yes, go ahead, lie, and then lie some more about Gary, and it's okay with me. Well, fuck that. Anyway, so, alright, so now we'll go to Pyrrho's answer to the questions. We'll go to one of them, and then, you know, we'll have to do other people at some other time. Alright, so Pyrrho's answer should be up here, right? Okay. Oh yeah. Put them below. Red circle. No, that they're useless answers, obviously. So he said, okay, Pyrrho himself has answered all these questions, which was nice of him. I mean, what? Jesus, what a joke. I'll put them below. I mean, it's just amazing. You know. Suck up much? Anyway, if a person used the same effort to throw an 8-pound ball and a 16-pound ball. So I thought by saying effort, I destroyed all of this nonsense about how I somehow don't get the energy into the ball. Does the 8-pound bowling ball have twice as many joules of energy to give to the pins? So now, even though physics has said this to lots of people, obviously there's a, as I showed, there's a book written where physicists explain to bowlers that you can derive more energy by using a lighter ball. So it's clearly something physics does say. So he overtly says no. Okay. The effort is the same, energy used by the person, and goes into the balls when they have the same kinetic energies. So he's saying they have the same kinetic energies but different momentums. And the only way they can have the same kinetic energy is that Professor Lewin is wrong, that somehow I use the same energy and I somehow can't make the 8-pound ball go twice as fast as the 16-pound ball, or when I throw the 16-pound ball, somehow it goes still really fast, 70% of the velocity. I don't have to lose half the velocity to throw the heavy ball. I get to keep 70% of my velocity, which makes no sense at all. So the answer is idiotic. Right, yes, it's idiotic. Okay. All right, the same explosive charge will make a dime go 1,000 miles an hour, or 2 kilograms go a mile an hour. Now, I didn't realize I had to say in space, right? We wanted to do this experiment in space. Okay, so unfortunately I didn't say. So Piero has watched none of these videos, so just understand that he has absolutely none of the context you probably have, certainly. But I mean, it's like he is paying no attention to the actual arguments. He has such a peripheral understanding, so he doesn't even know this question. Okay. How can the same charge energy give the dime 1,000 times more energy? If we collected the energy of the bottle and the dime, do you think the dime will actually be found to have 1,000 times the ability to do work? So this is just convoluted mush, but I'll read it. The same explosive charge has energy E. Well, isn't that interesting? I could say it has energy M, momentum, but whatever. The 2 kilogram mass and the dime will have the same kinetic energy. So, I mean, he's overtly saying that the bottle has like no momentum at all. Nothing. No, the bottle has huge momentum when it can't possibly have huge momentum. It's only going 1 mile an hour. So he's saying that the bottle has to leave at a much higher velocity than it actually does. That's the only way he can fix it. So he's saying that it isn't true, that the same explosive won't create 1,000 miles an hour and 2 kilograms to go 1 mile an hour. He's saying that isn't true. So I got that exact phrase from one of the trolls arguing with me, right? Saying, how could you possibly believe the dime is the same energy as the 2 kilo, right? So I mean, I got this from someone arguing against me, and yet Piero's arguing against that. So a guy who's on Piero's side made this argument, and they can't even agree on the physics. You see, they're saying that this is all settled truth, and they can't even agree on any of the premises. So they can't even get these fundamental premises right. You know, how fast, so if I use the same energy, will the dime go 1,000 miles an hour, and how fast will that same force make 2 kilograms go? So Piero's saying it'll make 2 kilograms go like 100 miles an hour, much faster. So he's denying that this physics is true. All right, the dime will go faster for obvious reasons. No, there's nothing obvious in any of this. You have to think about all of it. And the velocity it goes can be calculated from the energy and mass of the object. So he's just providing the same stupid formula and saying, look, no, this doesn't mean anything. Where did you demonstrate any of this? Okay, so when you collect the energy, you will find they have the same kinetic energy. Well, what I'll find is that the premise of the whole experiment has been defeated by your assertion that the bottle is going 100 miles an hour when it's not. So he just completely broke the experiment. There's no point because he's changed the premises of the experiment. All right. It is based on a battery. It is stored in a battery. It will be the same, whatever that even means, except for all the minor untracking losses to friction, heat, bumping into mosquitoes. Obviously, there wouldn't be any of that stuff in space. So that's why it would have been much better if I had put the space word, because he just he didn't watch these videos, so he has no clue what this argument's about. You can't use all those fake excuses. So now he's saying that somehow it still doesn't make any sense. Like I said, he's saying if you concede that the dime is going 1,000 miles an hour, he has to make them have the same kinetic energy, he has to make the momentum of the bottle much, much higher. So the bottle can't be going 1 mile an hour, it has to go 100. The work energy they could do is the same in amount. So again, it's just, yes, it is actually the same, but not if the bottle's going 100 miles an hour. Not if the bottle has the same, not if you increase its momentum. He's changing the momentum of the bottle. So understand, you can't do that, frankly. This is called the conservation of energy and the destruction of momentum. So again, it's conservation of energy when they want it to be, and then it's conservation of momentum when they want it to be, and they never realize that you can't have these contradictions. Momentum is energy. You just can't play this game of, I only have to conserve one of them. You can't do that. And mainstream science, so here we go, and mainstream science says it's universal. So he just made a declaration. When mainstream science, I can show you physicists, who've responded to my post on Quora, and they agree that the two objects have the same momentum. So, so he says, what science says. No, it's not what science says. The energy lost to friction, heat, and mosquitoes, it says the same bullshit again. So this is just like physics, girl. I completely 100% transferred the momentum, but I lost 50% of the energy to heat and sound and noise and running over cats and whatever else. Bullshit you did. You can't use the momentum twice. Okay. Comes from the same total that started with explosive charge. So just complete crap. And then he updates it with horseshit. Update. I see that red circle answers perhaps you mean one charge throwing both of them at once. No, I didn't mean that. I didn't care. It doesn't make any difference whether I use one charge and shoot the two things in opposite directions or I use individual charges. It makes absolutely no difference. Newsflash. If this is the case, then the only difference is that some energy will go to the dime, well, duh, and some to the 2 kilograms. How much will go to each is that they will each end up with the same momentum. So now he says they have the same momentum. How can they possibly have the same momentum when you just said they have the same kinetic energy? So their total momentum, which starts at 0, stays at 0, which again is too stupid, because we know none of them have 0 momentum. Afterwards, the total momentum is 0 because momentum is an arrow. Isn't that a great explanation? Momentum's an arrow. And so he's conceding now that the momentums will be the same. So just get me. Now he's saying the momentums will be the same. And now the paradox is obvious because the dime has 1,000 times more energy. So how can the dime have 1,000 times more energy from the same force? How does that make any sense? How could the same force manifest 1,000 times energy this way and 1,000 times less energy over here? How is that equal and opposite reaction? Which way does the spaceship go? See, we lost all of the... So now he's basically saying that, he has to account for all that kinetic energy. What's he going to say? The spaceship tilts way over to the left? Yeah, I mean, this is so convoluted. So he's directly contradicting his first answer with his second answer. So anyway, afterwards, the total momentum is 0 because momentum arrow and the objects will be moving in exactly opposite directions with different speeds. That is, and then he just gives the formula. So it means absolutely nothing. So complete non-answer. First answer, and he completely contradicts it with the second answer, and completely evades the fact that, well, if they have the same momentum, the theory is you created 1,000 times more energy that way, than that way? And how do you account for that? Will the dime going 1,000 miles an hour do more work in the universe than the 2-kilogram bottle going 1 mile an hour? Will they do different amounts of work? And you're saying, yes, they will, because it's real kinetic energy. And so how did you get more work to go that way than that way? And if you do this, won't your spaceship go that way? Dramatically. All right, so terrible answer. The third one he just completely gives up on. Can you provide an example of Newton getting a wrong answer using momentum to describe interactions? So this would just require you to say, well, yes, Newton would have done this wrong. He would have done that wrong. Everything he would have put on his shoes the wrong way because he just didn't understand how energy works. Okay, Newton without kinetic energy would not be able to calculate how much momentum is in a coiled spring. So an absolute nonsense. How do we tell how much energy is in a coiled spring? We measure the energy of the things that leave. That's exactly how we measure it. You measure the amount of heat. You measure the amount of deformation. We measure these things. So how could he's basically saying Newton didn't know how to use a ruler? Of course he did. Of course he knew how springs work. Of course he knew that he could weigh things with springs. I mean, what a pile of absolute crap. Okay, the reason why is springs don't store momentum; they store energy. So more absolute nonsense. So he just conceded they have to give the same momentum, obviously storing momentum. Just nonsense. Okay, the only way to find out how much momentum is in the moving object after the energy is changed to kinetic form. So somehow he's conceding now it is momentum and somehow it turns into kinetic energy. And that somehow I can make 1,000 times more going this way, and I don't have to worry about the equal and opposite reaction that way. Okay, is this the is with the kinetic energy formula? So again, the made-up, silly, religious notion of squaring a velocity for absolutely no rational reason. Also, I don't believe Gary has ever seen Newton get a right answer. So this is horseshit. Obviously, I didn't see Newton do anything personally, but I am quite aware of Newton's predictions and Newton's mechanics. So that's just horseshit. He just heard that it happened, like everybody else. But regardless, I'm just saying, in what I'm seeking an example where they can show how, gee, this is where Newton would have gotten a wrong answer. There is no example, right? There's no example provided, no experiment you could do that would have fooled Newton. So just more bullshit. Alright, so that's enough for this video. Yeah, this is obviously going nowhere. Bro's answer was really quite funny, so I'll probably pick some pieces out of that. Most of it was just rambling nonsense, but he's saying he's not an expert on any of this. Yet he's making claims as if he's an expert. Right? I mean, he's clearly saying he's smart enough to tell me I'm wrong. That he knows enough to tell me I'm wrong. Which is just hilarious. But the really funny part was in a moment in the text he's conceding he might be wrong. So he thinks it is possible that Gary is right. And then, ooh, that's not going to be any fun. Well, especially considering how obnoxiously arrogant you've been. Yes, it's probably not going to be any fun for you at all. But just the fact that he's conceding. So that's how much confidence he has in his own experiments. He knows, well, maybe Gary's right. Because he knows his experiments are doubtable. He knows they're shit. So even though he's sold it as absolute proof, he knows it's shit. Alright. So just, whatever. I had no expectation that, going into this. I really did think you could reason with human beings. That smart people really did like understanding the truth. They like being able to put pieces in the right places. They like doing all that kind of stuff. They like controlling you know, and being certain. And you know, I guess that's the problem is that they've been totally invested in this science thing as some source of truth. And you know, and I just never had that much confidence. I mean, I took each bit of science, you know, a piece at a time, and I didn't assume just because they say so it's true. And you know, so maybe that's part of the difference. I don't know. They seemed fallible to me. I mean, you know, you hear a little bit of the history and you kind of get that, you know, they didn't agree with each other, and it was, you know, these aren't settled issues entirely. So I guess I could just go back to the photon drawing. Was just so bad. I was like, come on, you can't believe this is what a photon is doing. You can't do it. You can't. You can't believe something this silly. So, you know, it just, you know, there is some point. I guess you could just add up a few of these places where science said something, and I was like, nah, that ain't gonna happen. All right, but anyway, I don't need this. I don't know why I'm playing with it, but it's, you know, it's a habit, some sort of thing. I won't bother trying to analyze that, because that would just be a waste of time. So, anyway, so till the next time. This has been a DraftScience video communication. That's what it's been. Until the next time and such.